Alrighty, folks, this is page 3 of your Chapter 6 study guide. So this page especially is all about graphing. The 25 through 27, it says provide the details of the graphs below. If there is no particular transformation, just write none. Be sure to also graph the midline as well as the two dotted lines to indicate where the maxes and the mins should land. So my recommendation is to do all of the algebra first. Okay, do all of the algebra first and then go through and then graph your midline and stuff and then go through and actually graph your points and your curves. So just to recap, if we have y equals a, and then it doesn't matter what the function is, I'm just going to put sine, a times the sine of k theta plus c plus h. On page 2, we already discussed how a is amplitude. We discussed how k is not the period. K helps us with the period because the period is equal to 2 pi over k. Okay, C, similarly to the period, C is not the phase shift. However, it helps us with the phase shift because the phase shift is found by doing negative C over K and then plus H, that is your vertical shift as is. Okay, so let's find this information first. Number 25, the amplitude, I've got my A value is 3, so therefore my amplitude is 3. My period, again, is not always necessarily 2, but notice how I have no, well, we'll talk about phase shift in a second. My period is 2 pi over k. Well, 2 pi over my k value is 2. 2 over 2 is just pi. So my period is pi. My phase shift, there is no c value. Therefore, that would be 0 over my k value is 2, which is still just 0. So in this case, there is no phase shift. So I'm going to put none. And then my vertical shift dealing with h is going to be negative 2, which means down 2. Downward 2. Using this information only, I can go ahead and graph where I know my midline should be and where my maxes and my mins should hit. The midline is given to us by the vertical shift. If it's down 2, I know this is kind of the center of my curve. If my amplitude is 3, that means I can go from here up 3 to positive 1. And this is where my max points should hit. And then down 3 to negative 5, this is where my mins should hit. So remember, that's what amplitude is. It's the distance away is going to be 3 on both of them. Only at this point can you go ahead and plug the function into your calculator, adjust your window as necessary, right? Go from 0 to 2 pi. Your x scale, it counts by pi over 2s. So make sure your table set is also pi over 2. And then if you look at your table, you should get some lovely looking points. At 0, you get negative 2. At pi over 4, your next, and of course it's in decimal form, you're going to get 1. At pi over 2, you get down to negative 2 again. At 3 pi over 4, you get your min value of negative 5. And then notice there's just a pattern, right? Up to your max, back down to your midline, down to your mins, back up to your midline, and then from there we can go ahead and make our curve. So it's going to look something kind of like this. And again, the period of pi means it makes one revolution from 0 to pi. You should see the entire sine curve, and you do. So its frequency in this case would be higher. Number 26, y equals 2 times the cosine of theta over 2 plus pi. So again, let's go through our algebra first. Amplitude, my a value is 2. Period is found by doing 2 pi over k. So I've got 2 pi over my k value. Notice if I have theta over 2, that means my k value must be 1/2. And then 2 divided by 1/2 is the same thing as doing 2 pi times 2 over 1, or just times 2. Okay, and then 2 pi times 2 is 4 pi. So this time it's going to take twice as long for my graph to get through one period. Phase shift is found by doing negative c over k. So again, I have my C value is pi. So it's going to be negative pi over the K value is 1/2. So again, you may want to, I'm running out of space. So you may want to do negative pi instead of divided by 1/2, it's going to be times 2/1. So that's going to be negative 2 pi, right? So if that's negative 2 pi, then that means our phase shift is going to be to the left 2 pi. And then the vertical shift, there is no plus h, which means none. There is no vertical shift. Now, in your calculator, well, let's go ahead and do our lines first. Our amplitude is 2. Again, there was no vertical shift, which means our midline is just going to be the x-axis, just as it is in the parent function. And then if I have an amplitude of 2, my maxes should hit at positive 2. My mins should hit at negative 2. From there, when you plug this into your calculator, you have to make sure in the y= section of your calculator that you use parentheses around theta over 2 in your calculator. So in calc, use parentheses around theta over 2. So in that case, you're going to have a double set of parentheses. Otherwise, your calculator is going to, well, in this case, it actually wouldn't matter. But typically around fractions, you want to be careful. For 27, it's going to matter. But for this one, you'd actually be okay. Anyway, it's a good practice. Okay, when you plug that in your calculator, notice this x-axis goes all the way up to 12 pi. So this one you definitely would want to change your window and your table sets. Notice it's counting by pi's. So your x scale and your table sets, you both, table set, you want those both to count by pi's this time. And then if you plug it into your calculator to get your curve at 0, again, you would get very nice numbers. You'd get negative 2, up to 0, up to positive 2, back down to 0. And again, you can just, hopefully by now y'all are getting used to the pattern where each of these points should land. And then if we go ahead and sketch the curve, you should get something that looks like this. So it looks like it has a high frequency, but again, remember, your x-axis is actually going all the way up to 12 pi. So if I stretch this out to the same scale as, the graph for number 25 per se, it would actually be a lot slower curve if we were talking time. Number 27, I have another cosine graph. Again, let's do the algebra. Amplitude, there is no a value in front of the cosine, which indicates my amplitude is just 1. Period is 2 pi over k. Well, my k value is 1, right? There is no value in front of theta, which means my period is just 2 pi. So it's a regular period. And phase shift is going to be negative c over k. Well, again, if k value is 1, then it's just going to be negative c, which is negative pi over 2, which indicates it's going to be to the left pi over 2. And then a vertical shift is going to be my plus h. So since it's plus 3, that means up 3. So if I graph my midlines, up 3, this would be the midline. An amplitude of 1 means at 4, our maxes should hit. And at 2, our mins should hit. This is the one for sure in your calculator. You have to make sure in the y= section, when you plug in cosine of theta plus pi over 2, that you put pi over 2 in parentheses in the calculator. Sorry, my writing is not lovely right now. In calc, pi over 2. Because your calculator needs to know that that fraction goes all together. Otherwise, it's going to add, well, actually, would that one matter as well? Now I'm second guessing myself. I'll say this, parentheses don't hurt anything, okay? It's always better to put your fractions in parentheses no matter what. Either way, when you plug that in your calculator, again, you should get some lovely numbers. At 0, you'd get 3. At pi over, okay, so notice, be careful here. See how it's by pi over 2? That means we're actually counting by pi over 4. Okay, so at pi over 4, you're going to get a crazy decimal. But then at pi over 2, you get down here to 2. Okay, so you're going to get crazy decimals at all the fourth pi's. But at pi, you're again up to 3. At 3 pi over 2, you're up to 4. Back down to your midline. At 2, oh wait, both of those are wrong. Shoot. Okay, let me repair my midline. Okay, at 2 pi, we're at 3. 5 pi over 2, we're down here to 2. At 3 pi, we're back up to 3. So your curve will look like this. Okay, so that's how you graph these functions. Now, number 28 and 29, I'm giving you information. I'm asking you to go backwards and give me the equation with this information. Okay, so number 20, first of all, the tangent function. When it says a period of 2 pi, that's typical. Okay, so that means, you know, k value, if period is 2 pi, if period is 2 pi over k, but then I tell you that the period itself is 2 pi, then the only way for that to be true is that k must be equal to 1. Okay, so a period of 2 pi means k is equal to 1. If I have a phase shift of pi, you could find c if you want, but you could also just use what you know about, okay, if it's a phase shift of pi, if it's positive, then that means we're going to be going to the right, okay? And then vertical shift of 4, of positive 4, means that h is going to go up 4. So this equation would be y equals, again, I have no amplitude change, so just the tangent. And actually, I should write plus or minus the tangent, because it could, amplitude could be the, a could be 1 or negative 1. So plus or minus the tangent of, I have no k, or k is 1, so I've just got theta. If it's to the right pi, then that means I'm going to have minus pi in parentheses. And then a vertical shift of positive 4 means plus 4. If that phase shift confuse you, remember that phase shift, I'm going to write as PS, is negative c over k. And if it tells us that the phase shift is pi, then that means pi is equal to negative c. We already solved for k is equal to 1. And the only way for this to happen, again, if you cross multiply, is if c is also negative pi in order for that to be equal. And 29, I'll do a little bit more algebra for you to solve if you need it. Okay, so for 29, I've got the sine function. This time I do have an amplitude change, so I know a is 1/4. Period is pi instead of 2 pi. So what that means is I have, let me do that work down here. If my period is found by doing 2 pi over k, I know that if pi has to equal 2 pi over k, the only way that this works is if k is equal to 2. Hopefully you can see that, because 2 over 2 is pi. Or if you need to go through the cross multiplication, then you get pi k is equal to 2 pi. Divide both sides by pi, and then you get k is equal to 2. So there's your other variable. So we already have a, we have k. And then for phase shift, we know that it's 3 pi over 2, right? So again, phase shift is found, I'm just going to go ahead and write it on here. Phase shift is found by doing negative c over k. Okay, so this means that if I cross multiply, I have 3 pi k is equal to 2 times negative c is going to be negative 2c. And then if I want to solve to get c by itself, divide both sides by negative 2. So then I get c is equal to, oh, hold on, I know what k is. Why didn't I plug it in? It's okay. I know k is equal to 2, so let me plug that in here now. That's going to be 3 pi, k is 2 over negative 2. So it's going to be 6 pi over negative 2, which is going to be negative 3 pi. Okay, so c is negative 3 pi. So my final answer will be y equals plus or minus 1/4 times the sine of, my k value is 2, so k theta would be 2 theta. And then it says plus c, but I know that c is negative 3 pi, so that'll be minus 3 pi. And then there is no vertical shift, so there is no plus h to take care of. Number 30 is simply a matching game. So you could either use what you know about the co-functions of sine and cosine, and hopefully you know from the get-go that E is going to be the sine of theta because it goes through the origin, that C is going to be the cosine of theta because it starts there at 1, and those are our typical curves. The other one of the regular basic trig functions is going to be the tangent of theta, okay, and it is positive. The other easy one from here is going to be cotangent because it takes tangent and basically flips it upside down and shifts the asymptotes over a little bit. In your calculator, so if you get confused with the other ones like A and D, here's the tricky parts. In your calculator, if I want to write or graph the cosecant, so to speak, of theta, I would have to enter in my calculator 1 divided by cosecant is partnered with sine. So I'd have to put 1 over the sine of theta if I wanted to graph cosecant. If I wanted to check the graph of secant of theta, I would have to put 1 over the cosine of theta. And if I wanted to graph cotangent, I would have to put 1 over the tangent of theta. Okay, so if you're going to use your calculator, if you're not going to know what the graphs are just by knowing, if you're going to use your calculator, this is what you have to be mindful of. Now, here's the hint. If I graphed sine and cosine on the same graphs as their co-functions, the points are at the same spot. So you see how the points on sine, at pi over 2, it goes up to 1, and at 3 pi over 2, it's down at negative 1. That's what lets me know, okay, so if I look at these, at pi over 2, example D, you see how its point is still at 1, and at 3 pi over 2, its point is at negative 1. So actually, if I graph the sine function inside of this, that's how I know that these two are partnered together. So that's how I know that this one is the cosecant of theta, because they will share points. Contrarily, the cosecant has points at 0, 1, at 0, and then at pi it goes down to negative 1. So if I look at example A, I also have these points, 0, 1. At pi, I'm down to negative 1. So if I graphed my cosine function with this function, they share those points, and the asymptotes occur where the original functions cross the x-axis at 0. Okay, so that's how I know that those go together. So this one would be the secant of theta. So again, that's the logic behind it, or you can use your calculator and type in 1 over whatever function you're trying to find to know which of those crazy new graphs coincides with, sine, cosine, and tangent.